At exactly 2 p.m. Eastern Time today, the Miami Metro Rail stopped running. Not because of a mechanical failure, not because of a signal problem, not because of a power outage. The Metro Rail, the elevated transit system that carries tens of thousands of Miami commuters every day, was halted because Miami-Dade County's emergency department determined that a structural precautionary inspection was required before trains could safely continue operating. Emergency lines across multiple Miami neighborhoods had been flooded with calls from residents who felt something they could not explain. Officials ordered precautionary evacuations of certain buildings. And across South Florida, people who had been sitting at their desks, standing in their kitchens, riding elevators, and walking through office lobbies were all asking each other the same question. Did you feel that? They felt it in Sarasota. They felt it in Tampa. They felt it in Hollywood. They felt it in Palm Beach. They felt it in Tallahassee, more than 500 miles from where it happened. A person in Palm Beach posted a TikTok showing a houseplant rocking. Someone in Hollywood filmed a water cooler shaking. Someone in Tampa said they thought a truck had hit their building. Emergency call centers across Florida were overwhelmed with people trying to understand what had just happened to them. What had just happened to them was a magnitude 6. One earthquake. In the Gulf of Mexico, the strongest earthquake in the Gulf in 76 years. The second most powerful intraplate earthquake ever recorded in the entire history of scientific earthquake monitoring in this body of water. In the Gulf of Mexico, a place that is not supposed to have magnitude 6 earthquakes. A place where seismic hazard maps assign essentially zero risk. A place where nobody, not the people who designed Miami's buildings, not the engineers who planned the Metro Rail, not the millions of Florida residents who chose to live there, has ever had to think seriously about earthquakes. Until today. I want to walk you through exactly what happened, why the Gulf of Mexico can produce earthquakes at all when the conventional wisdom says it shouldn't, what would have happened if this earthquake had been bigger, and what this means for you if you live anywhere on the Gulf Coast. Because I think this event is more important than most of the coverage is treating it, and the reason most of the coverage is treating it as a curiosity rather than a serious story is exactly the same reason it's a serious story. Nobody expected it. Let me start with the facts, as they are confirmed right now. The earthquake struck at 2 p.m. Eastern Time in the Gulf of Mexico, with its epicenter approximately 65 miles northwest of the western tip of Cuba. The USGS confirmed a magnitude of 6. Initially the magnitude was reported as 6. 4 before being revised downward, which is standard procedure as more seismic stations contribute data. The depth was 26 kilometers, approximately 16 miles below the seafloor. Shaking was felt across the entire state of Florida, not just in South Florida, which is closest to Cuba, across the entire state. From Key West to Pensacola, the ground moved. The USGS confirmed reports of shaking from numerous locations. Seismic waves traveled more than 500 miles from the epicenter before reaching Tallahassee. In Miami specifically, buildings swayed, not collapsed, not cracked, but swayed, perceptibly, noticeably, enough to stop Miami Metro Rail in its tracks and send people out of their offices and into the streets. The shaking was also felt as far away as Cancun, Mexico, according to reporting from courts. Across the Straits of Florida, Cuban state media reported no deaths or major structural destruction, though officials noted that data collection from more remote areas was still ongoing. Cruise ships at Cozumel and Costa Maya, Disney Destiny, Carnival Jubilee, Carnival Breeze, Royal Caribbean's Radiance and Enchantment of the Seas, had passengers reporting unusual vibrations, though no ship damage occurred. The National Tsunami Warning Center issued a statement confirming no tsunami threat. No deaths have been reported. No structural damage has been confirmed anywhere in the United States. So why does this matter? Why is this not just a curiosity from a day when Florida felt something weird? Because of what this earthquake tells us about a risk that 15 million people living along the Gulf Coast have never been asked to think about. Here's the thing about the Gulf of Mexico that you need to understand. It is not supposed to produce earthquakes of this size. The way earthquakes work, at the most basic level, is that they happen at the edges of tectonic plates, the massive slabs of rock that make up the Earth's outer layer. California shakes because it sits on the boundary between the Pacific and North American plates. Alaska shakes for the same reason. Japan shakes. Indonesia shakes. These are plate boundary zones, and they are the primary sources of the world's earthquakes. The Gulf of Mexico is not a plate boundary. It sits in the middle of the North American plate, far from any active fault system, in a region of thick, old, relatively cold rock that has been geologically stable for tens of millions of years. The conventional seismic hazard maps for the Gulf Coast assign very low earthquake probability for exactly this reason. The Gulf is supposed to be quiet, and in general, it has been quiet. Only 6 earthquakes of magnitude of 5 or larger have been recorded in the Gulf in the past 76 years. 6 in nearly 8 decades. Compare that to California, which records 6 or more magnitude 5 earthquakes in a typical month. But today was the 7th. And at magnitude 6.1, it is the largest Gulf earthquake since a magnitude 6. 4 struck near Veracruz, Mexico in 1959. Before today, the only comparable event in the modern record was 67 years ago, and the only historical event of similar size, an estimated magnitude 6. 0 earthquake near San Cristobal, Cuba in 1880 was 146 years ago. When that 1880 earthquake struck, it caused building collapses and killed people in Cuba, and it was felt across the Florida Straits in Florida, just as today's was, a building-damaging, casualty-producing earthquake in the same region as today's event. 146 years ago. The USGS classified today's event as an intraplate earthquake, meaning it happened inside a tectonic plate, not at a boundary. This is rare. Intraplate earthquakes happen on ancient faults, structures formed hundreds of millions of years ago, buried under sediment, showing no surface expression, and producing essentially no background microseismicity that would allow scientists to identify and map them. Wendy Bohan, an earthquake geologist quoted by Scientific American today, was explicit. No earthquakes beyond magnitude 5. 0 have been recorded within 250 kilometers of this quake. In other words, the fault that just moved today, the ancient structure that produced a magnitude 6. 1 earthquake in the Gulf of America was essentially unknown to science before 2 RPM this afternoon. That is the terrifying part, not the shaking that people felt today. The fact that the ground moved on a fault we didn't know was there, that gave us no warning, that appeared on no hazard map, and that has done this before. I want to talk about what happened in Miami specifically, because I think it illustrates something that is not getting enough attention. Miami is a city of glass high-rise towers built on reclaimed wetland and limestone bedrock. Its building codes have virtually no seismic provisions, because the standard seismic hazard assessment for South Florida assigns extremely low earthquake risk. The buildings in Miami were designed for hurricanes. They were designed for flooding. They were not meaningfully designed for earthquake shaking. And today, those buildings swayed perceptibly, enough to prompt emergency calls to 911, enough for Miami-Dade County to halt Metrorail operations for precautionary inspection, enough for officials to order precautionary evacuations of certain buildings from an earthquake with its epicenter 300 miles away in the Gulf of Mexico at a magnitude of 6. 1. University of South Florida. Seismologist Jochen Braunmiller told the New York Times that colleagues of his working in a Tampa building 300 to 400 miles from the epicenter felt the tremor. He estimated the shaking they experienced was at the lower end of the perceivable scale. Noticeable, but not alarming. In Miami, closer to the epicenter, the shaking was more significant. Now I want you to hold those facts in your mind and ask yourself a question. If a magnitude 6, 1 earthquake, 300 miles away in the Gulf stopped Miami's transit system and prompted building evacuations, what would a magnitude 7.0 have done? What would a magnitude 7.5 have done? What would a magnitude 6, 1 with its epicenter not 300 miles offshore but 50 miles offshore have done? I'm not predicting any of those events. I'm not saying they are imminent. The geological record suggests they are rare, very rare. But the geological record also tells us that the Gulf has produced damaging earthquakes. That 1880 earthquake killed people in Cuba. That was a magnitude 6. 0. At a similar location to today's event, with 146-year-old Cuban building construction, yes, but also with far fewer people living in the affected area than live along today's Gulf Coast. Today's Gulf Coast is home to roughly 50 million people. The cities of Miami, Fort Lauderdale, Tampa, Sarasota, St. Petersburg, Naples, Fort Myers, New Orleans, Mobile, Biloxi, Gulfport, Houston, Galveston, Corpus Christi, Brownsville, major petrochemical facilities along the Texas and Louisiana coast, the Port of New Orleans, the Port of Tampa, offshore oil and gas infrastructure throughout the Gulf Basin. None of this infrastructure was designed to a meaningful seismic standard because nobody, not engineers, not city planners, not the federal government, has been treating Gulf seismic risk seriously. Today's earthquake is a data point that should change that. Not dramatically, not overnight, but seriously. Let me explain why the earthquake was felt so far away, because the physics is actually one of the more alarming aspects of this story. The Gulf of Mexico basin is underlain by thick layers of soft sedimentary rock, limestone, sandstone, and salt deposits that have accumulated over hundreds of millions of years. When seismic waves travel through these soft sedimentary layers, something happens that doesn't happen in hard crystalline bedrock. The waves are channeled and amplified. The sedimentary basin acts like a pipe, guiding seismic energy northward through the Gulf and delivering it to the surface far beyond the distance where it would normally be detectable. This is called basin amplification, and it is the same phenomenon that turned a distant earthquake into a catastrophe in Mexico City during the 1985 Michoacan earthquake. That event had its epicenter 350 kilometers from Mexico City, but the soft lake bottom sediments beneath Mexico City amplified the long-period seismic waves so dramatically that shaking intensities in the city were comparable to a much closer earthquake. More than 5,000 people were killed in Mexico City from an earthquake that originated hundreds of miles away, because the geological architecture of the Mexico City basin focused and amplified the energy. The Gulf of Mexico has a similar architecture. The thick, soft sedimentary sequences beneath the Gulf Basin are efficient transmitters of long-period seismic waves. And Florida's own geology, the thin, porous limestone and unconsolidated sediments underlying much of the peninsula, is itself prone to amplification effects. The combination of Gulf Basin channeling and Florida's amplifying soils is why Jochen Braunmiller and his Tampa colleagues felt a Gulf earthquake from 300 to 400 miles away, and why buildings swayed in Miami. For magnitude 6, 1 at 26 kilometers depth, the energy available is manageable. But the basin amplification factor applies regardless of magnitude. A larger Gulf event, one closer to the continental margins, one shallower, one larger in magnitude, would deliver amplified energy to the same Florida coastline, to the same Miami high-rise towers, to the same Tampa Bay waterfront that felt gentle shaking today. Here's what the historical record actually tells us about Gulf seismic potential, because I want to be honest with you about both what we know and what we don't. In the past 76 years of instrumental earthquake monitoring, only 6 magnitude 5 or larger earthquakes have been documented in the Gulf. Today's 6, 1 is the 7th and the largest since 1959. That is a low rate by any comparison to plate boundary regions, but instrumental recording only goes back 76 years. The geological record of earthquakes in the Gulf goes back thousands of years, and that record is much harder to read. Unlike plate boundary regions with frequent earthquakes and well-mapped fault systems, the Gulf's intraplate structures are buried under sediment, rarely produce microseismicity that would allow scientists to identify them, and may have recurrence intervals, the average time between major earthquakes, that stretch for centuries or millennia. The 1880 San Cristobal event suggests a recurrence in the same region of at least 146 years, possibly much longer. We have 2 data points, 146 years apart, of comparable events. That is statistically insufficient to estimate a meaningful recurrence interval. The next comparable event could be in 50 years. It could be in 300 years. It could be in 1,000 years. Geology does not answer that question. What geology does tell us, and what today confirmed, is that the structures capable of producing a magnitude 6 class earthquake exist in the Gulf, that they are not on any seismic hazard map, that they give no warning before rupturing, and that when they do rupture, the shaking reaches the Gulf Coast in ways that the region's building stock and infrastructure are not designed to handle. Susan Hauff, the USGS seismologist quoted by Scientific American, noted today that the Caribbean has its own ring of seismic activity, the boundary between the North American and Caribbean plates, and that today's earthquake happened away from that boundary in a way that warrants further scientific investigation. The fact that a M61 event on an unmapped, unknown fault in the Gulf's interior can disrupt Miami's transit system and prompt building evacuations in 2026 is a sign that the hazard assessment for this region is incomplete. I want to address the cruise ship angle specifically because it adds a dimension to this story that I think is both humanizing and informative about the geographic scope of today's event. At Cozumel, Mexico, when today's earthquake struck, 3 major cruise ships were in port: Disney Destiny, Carnival Jubilee, and Carnival Breeze. At Costa Maya, 2 Royal Caribbean ships, Radiance of the Seas and Enchantment of the Seas Warner, were also present. Passengers and crew on all 5 ships reported feeling unusual vibrations during the earthquake. This was not dangerous. Modern cruise ships are large, stable platforms that absorb seismic waves efficiently, but it illustrates that today's earthquake was felt across a geographic footprint stretching from Cancun, Mexico to Tallahassee, Florida, covering an area of the Gulf Basin spanning hundreds of miles in every direction. Cozumel is approximately 600 miles from the earthquake's epicenter. Tallahassee is approximately 500 miles, the fact that a magnitude 6. One intraplate earthquake was felt at distances of 500 to 600 miles, producing perceptible vibrations on cruise ships, swaying buildings in Miami, stopping an elevated transit system, and generating emergency calls across an entire U.S. state, is a direct consequence of the Gulf Basin's geological architecture and the efficiency with which it transmits seismic energy over long distances. A larger event, a shallower event, an event closer to the Gulf's northern margin. Any of those conditions would deliver more energy to the Gulf Coast than today's earthquake. Not dramatically more shaking at the distances felt today, but significantly more at intermediate distances, the distances at which Gulf offshore infrastructure, coastal communities, and petrochemical facilities actually sit relative to the potential source regions. No tsunami. I need to address this because it will be the first question many viewers have. The National Tsunami Warning Center confirmed no tsunami threat. The physics is clear. A damaging tsunami from an intraplate earthquake generally requires a magnitude above 6, 5 at a depth of less than 20 kilometers, because the seafloor displacement needed to displace a column of water catastrophically requires more energy at shallower depth. Today's event was magnitude 6, 1 at 26 kilometers, on both counts below the typical threshold for significant tsunami generation. The nearest fault line to today's epicenter is south of Cuba, where the Caribbean and North American plates meet. An earthquake on that boundary, a plate boundary earthquake, would have very different tsunami potential than the intraplate event that actually occurred today. The Gulf's specific geometry, with its relatively shallow continental shelves around most of its margin, provides some natural attenuation for tsunamis that do form in its waters. But it does not provide immunity. Submarine landslides, which can occur independently of the direct tectonic mechanism, remain a Gulf tsunami risk on their own terms. For today's event, no tsunami, no threat. The Gulf Coast is safe in that specific sense. Let me close with what today actually means, practically, personally, and for people who live on the Gulf Coast. The Gulf of Mexico is not a high seismic risk zone by global standards. It does not approach California or the Pacific Northwest or Alaska or the New Madrid seismic zone in terms of earthquake probability. Living on the Gulf Coast is not seismically equivalent to living in San Francisco. The earthquake that happened today is rare. The probability of a damaging earthquake affecting Gulf Coast cities in any given year is low. But low probability is not zero probability. And the consequences of a significantly larger Gulf earthquake, a magnitude 7, 0 striking beneath Gulf Coast, waters closer to the continental margin, with Miami's towers swaying not gently but dramatically, with Tampa's coastal infrastructure absorbing amplified seismic waves, with petrochemical facilities along the Texas-Louisiana coast experiencing ground motion they were never engineered for. Those consequences could be severe in ways that the region is completely unprepared for. Today's earthquake shook people awake, in a literal sense. It moved their houseplants and their water coolers and their chandeliers. It stopped a major metropolitan transit system. It prompted building evacuations. In a figurative sense, it should shake people awake in a different way. The Gulf of Mexico has earthquakes. Ancient faults buried under its sediments have residual stress. That stress finds release, very rarely. And when it does, the entire Gulf Coast feels it. The last time a comparable event caused damage and fatalities in this region was 146 years ago. The population of the Gulf Coast today compared to 1880 is not comparable. The infrastructure at risk today compared to 1880 is not comparable. The warning systems, evacuation plans, and building codes in place for seismic events along the Gulf Coast today compared to what California has built over the last 50 years, that is also not comparable. One data point does not demand a complete reshaping of Gulf Coast hazard planning. But one data point, after 76 years of quiet, in a region that the geological record tells us has experienced damaging earthquakes before, is a reminder that the Earth's memory is longer than ours. The ground moved in Florida today. The ground is not supposed to move in Florida. Remember that. And make sure the people responsible for designing the buildings, the bridges, and the emergency response systems along the Gulf Coast remember it too. Subscribe and turn on notifications for updates as seismologists complete their analysis. Stay safe, Gulf Coast.